What is a sequence? It's a list of numbers in an order. How about list of ordered numbers? Now, do you guys have your calculators? You can borrow some of mine. If we're going to learn how to put it, and I'm going to remember how to put a sequence on my calculator. Pardon? I don't know how to do. I haven't tried it. Sorry. Do a Control T to get the table. Oh, and then I'm going to use the 84. If I can. There it is. I'll have to work on it. There is no way. You have to look at it and guess. That's what you're not going to like about this chapter, because you're going to be doing a lot of stuff like that. Yeah, this is huge. They won't ask you for a sequence, but this chapter is the AP. Sorry, I've got things going on at home. Okay. Okay, let's see if I can do this. Large screen. Okay, let's change our mode. And we're going to go to sequential. Not sequential, I'm sorry. Parametric polar sequence. So they're going to look like little N's. So they're going to be in sequence mode. I just leave it always in radian. Well, for physics, but we're going to use n factorial and n to the nth. So we want to graph that sequence. So enter. Did I get it? Okay, it's on there. Now I'm going to go back to what. Are we ready?
Yes, sir. We're good to go.
I don't know. I know, it looks really weird. Instead of using A's, they use U's. So this is my sequence. U of n is n factorial. So it's n, and it should come up with n when I press the X button. Kind of nice. Do you know where factorial is? Math. Probability. Is it 4? 4. These are your combinations and permutations too, if you need those ever on like an ACT or SAT. And then it's divided by n to the n.
I don't know how to get there on this calculator.
Oh, I don't know either. I'm sorry. Remember, I said I wasn't an expert. I'm intermediate user. And you can use mine. You don't have to do this. And then I want my minimum value for my n. So, my minimum value, sorry, it's set. It's 1. So then I'm going to do my sequences. Let's go press a window and see what that says. My n minimum is 1. My n maximum, I can do 10 of these points, is maybe big. And I'm not sure about the rest. So let's just graph it and see what we get. Probably nothing. Oh, it's not bad. But you know what? I only want the first quadrant, don't I? And you're only going to get the dots. I don't know if I can change it. But what I'm going to do is change it to zoom. And I only need the first quadrant. Now wait till we add these. Quadrant 1. Only if you have the new operating system. Otherwise, you'll have to manually do that. I don't like, no, I can't see it. What's the biggest value that the y value is going to be? It's going to be 1. So let's see if I can find it here. X min is 0, X max is 9. And it's just plotting the points. So I wouldn't touch that. The y min is 0, and the y max is, I'm at 9.4. I don't want to do that. Let's make it 1.1. It's kind of like zooming in on it. I'll see. I get a better picture. Oh, that's much better. There.
What's the initial term?
So the value is here at 1. It starts here. That's just a tick mark on my axis. And then it's this one. Then it's this one. Well, now you should be able to guess what's happening to my sequence. It looks like it's, I don't know where it is there. It's probably pretty close to the axis. Otherwise, it doesn't show. Oh yeah, there's a little dot there. And here it's even closer. So, the limit of this sequence is n goes to infinity of n factorial over n to the n goes to 0. Which means what about n factorial n to the n? Which one's stronger? The denominator. So we're going to maybe need to remember that n to the n is greater than n factorial. That's okay. In general, n factorial starts with n minus 1, n minus 2, n minus 3, dot, 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 3 times 2 times 1. Yes? You could go into the catalog. If you just go to the catalog, you'll just have to go through the whole. It will be all with all the symbols. Okay. I want to prove that that's really 0. So I have what? N factorial over n to the n. So what I'm going to do is write out some of these terms and see if I can get this to go to 0. I'm going to use the squeeze theorem. This is tricky. This is the second half of the assignment. It's probably like one problem like that. Will it be on the AP exam? No. But is it part of the curriculum in the Calculus 2 class? Yes. So I have to cover that. Okay, so let's do A1. Remember, we start with 1. You guys do your homework last night?
Yes, we all do, I think.
That's awesome. That's great. 1 factorial over 1 to the 1. A2 is equal to 2 factorial, 2 to the 2. A3 is 3 factorial over 3 cubed. Okay, let me write that out. That's 3 times 3 times 3. Oops, wrong order. 3 times 2 times 1, I did it upside down. Over 3 times 3 times 3. No, it's not that bad. What's this number? 1. And what's true about each of these numbers? They're less than 1. So this is, it's less than 1. So that's kind of nice to see that. And you multiply numbers that are less than 1, they get actually smaller. Let's do the fourth one before we jump to the end. It's 4 factorial. Let's see if I can remember how I want to do this. This is 4 to the 4th. So it's 4 times 3 times 2 times 1. And this is 4 times 4 times 4 times 4. That's 1. So that fraction is less than 1. Can we jump to the nth one? I might do a little bit of moving around with this. Well, we got to prove it. Oh, no, let's not prove. So what's a sub n? It's n factorial over n to the n. Okay, so what does that look like? It's n times n minus 1 times n minus 2 times n minus 3. And it's 3 times 2 times 1 all over n times n times n times n, whoops, n times n times n. We're almost there. Because you won't see what's happening. This is 1, right? What's true about each one of these little fractions? Because I have to compare this to something to use a squeeze theorem. That's less than 1, right? That's less than 1. That's less than 1. If you just go up here and look at these examples, this is less than 1. This is less than 1. So if I take all the product of all of these things, which is less than 1, what is this less than? 1 over. This is less than 1. If I take a number less than 1 times 1 over n, this is less than 1 over n. I have to use the squeeze theorem. Do you believe that this whole fraction is always less than 1 over n? This is less than 1. Well, let's look at this. What's 1 over n? It's 1/4. If I take this fraction, which is less than 1, and multiply it by a fourth, will it be less than a fourth? Yeah. Well, there's going to be a lot of things like this that are weird to see like that. And this one, too. This is 1. This is less than 1. This is less than a third. 2/3 of 1/3. Okay, so saying it that way, if you take 2/3 of a third, it's going to be smaller than a third, right? Okay? Yeah, it's hard, yeah, it's hard thinking. It's kind of fun, though. So if I take a fraction of 1 over n, it's less than 1 over n. And then what I'm going to do is take the limit. This is clearly bigger than 0, right? Because they're all positive numbers. And I'm going to take the limit as n goes to infinity of each piece. And the limit as n goes to infinity. Well, what's the limit of 0? 0. And I have all that done. And what's the limit of 1 over n? It's 0. Since this limit is 0 on the right and the limit on the left is 0, this is trapped between the two. Therefore, what has to be true about the limit as n goes to infinity of n to the n, no, it's n factorial over n to the n. Sorry, I almost did it upside down. It's what? It's 0 by the... Yeah. The hard part is to see the pattern, isn't it? Yeah. You may have to come back. I have this on a video. You may have to come back and look at it again. Think about it. I mean, it's hard when you're in a 56-minute period. You do have a problem similar to that. You want to find something you can compare it to. I can compare it to this 1 over n. By the way, what do we call that? Harmonic. Yeah, I'll get there. Okay. Hopefully we'll have time for questions. Sequence. We'll do the harmonic series, which is very powerful. Everybody knows what it is. I think that's kind of cool. No, not yet. But you will. The harmonic series will be adding up all these terms. Okay. Notice they're all positive. Do you believe that's going to 0 when you look at the picture? That's kind of cool. Now, I could also on the same screen graph 1 over n. I could also do that sequence. And maybe in the beginning it might be smaller than this, but at the end it's going to be lying above this. So it's trapped. So if you wanted to do that, well, let's see, what is 1 over n? When n equals 1, it's 1. So it's still the same. Then when n equals 2, it's 1/2. What was that? Did we do that? Still the same, right? But then eventually it's going to be like this. It'll be just a little bit above it. And we know that this goes to 0. The red ones go to 0. You can graph it. Okay. I have this thing. It's called r to the n. And actually, it is connected with chaos theory. I want to find values of r where this sequence will converge. Let's let r equal 2. So this is the sequence. A sub n is 2 to the f. That's an exponential, right? So the r is my variable. I want to find a value there that maybe that sequence will converge. Will this converge? The fraction will converge. Will r to the n converge? Because it's 2, 4, 8, I will say it wrong, 16, diverges. Okay? So if you were to like iterate on that, it's kind of like an iteration, it's not really. Well, that's instead of fraction. Where's the dividing point between the fractions and these other numbers? What's a nice number to try? We can do 1/2. So a sub n is 1/2 to the n. Remember what that graph looks like? 1/2 to the x. If the function converges, then the sequence converges. Well, here's e to the x, or 2 to the x. Here's 1/2 to the x. Does it converge? Yes. And you could do this. It's 1/2, 1/4, 1/8. I usually make a list, and that converges. What's a number between 2 and 1/2 that might be important? No, between 2 1/2. 0 is important. Between these two numbers. In other words, these values diverge at 2, but the fractions converge. Where does it change? That, by the way, in chaos theory is called the Julius set. It's that border where it's called a Julius set. It's from Francois Juliet. He was a French mathematician in the early 1900s, and he was looking at things like this. And when you're at that border, if you're on one side of the border, the function will behave in a certain way, and the other side of the border, it's totally different. So let's try 1. Okay, guys? Does it converge? Yes. This is 1, 1, 1, and 1. If you try r equal to 1.00001, then a sub n is 1.00001 to the nth power. Is that going to go off to infinity, or is that going to go to 0? It's going to go to infinity. Anything, 1, it stays stuck. This is called a fixed point. If you're bigger than 1, it'll go off to infinity. What if I get really close to 1 on the left side of it? It goes to 0. Okay? I don't know if I have enough 9s, it doesn't matter. To n goes to 0. I get totally different behavior depending on which side of 1 I'm on, no matter how close I get. That's really a strange thing. This is going to be convergent at anything at 1/2. We'll get to negatives. This one is convergent at 1. Is it convergent at -1? That's a different question. But this is kind of cool because this is, you watch Jurassic Park. There's a butterfly flapping its wings in one part of the world affects something else later on. Yes, it does. If you don't buy a lottery ticket, or if you do buy a lottery ticket, does that change? If you're just doing let's say you're just doing a drawing, does that change the outcome of the drawing? If you don't put your name in the hat, or if you do put your name in the hat, will you have the same winner? Not necessarily. You've changed the initial conditions. Well, Lorentz did this, was he 60s? Yeah, he was in the 60s, and he tried to look for a pattern in the weather, and he kept running this experiment because it was the very beginning of computers, and he finally decided, you know what? I'm just going to start my data wherever I left off. Okay, guys? In the beginning, he kept doing the same thing. He kept running out of time. He said, I'm just going to start my data where I left off. So he did. And he got a totally different result because the initial conditions had changed just ever so slightly. So if you're at 1 on one side of it, I don't care how close you get. You can get as close as you want to 1. It will diverge. And you can get as close as 1 from the left side. It will diverge. Lorentz also built a water. Lorentz was kind of a strange guy. He decided he wanted a 36-hour day. So he tried living a 36-hour day. So the nights and days got all mixed up. He said that wasn't a good plan. He didn't like that one, and he built a water wheel. And one of my former students, who was also now a good friend, and he was an engineer, and he got really bored one weekend, and it's kind of sad actually. And he decided to build a Lorentzian water wheel. And a water wheel, it's like a Ferris wheel with these little buckets, and there's holes in the buckets. So if you put the water in, you put water in, so some's going out, some's going in, and you would think it would always, it would always spin at the same speed. Not necessarily. If you don't get enough water in, it'll just get stuck. If you put too much water in, it'll just like do this. But there actually is a point. There's water leaking out, and there's water coming in. If you get that balance just right, that the water will come in and the Ferris wheel will stop. And then it's going to turn around and it might do this. And then it might do this, and it's going to go back. Those are really cool. But he spent a whole weekend building one. And I had a video of it, but I don't know where it is. I can ask him.
Let's make one. Let's make one.
There may be something on YouTube. Yeah. A Lorentzian water wheel. Lorentz was a very interesting guy. So, now what we do in chaos theory, you guys, you've seen Julia's sets, I think. You've seen the Mandelbrot sets. See those pretty fractal pictures? If you watch Star Trek, those are all done with computers, all those beautiful backgrounds. And they're fractals. And we can do this after the exam if you want. But basically the idea is, if you take a value and it goes to infinity, you color it. If it goes to infinity really fast, like 2 to the x goes to infinity really fast, that might be red. Whereas this 1 point with all those zeros in there, that's going to take a while. That might be purple. And the ones that get stuck back into 0 are black. And the border here, where they don't go anywhere, they're fixed, is called the Julia set. It's the border between those two things. So I can bring some pictures of those things, and maybe I can bring those in tomorrow so you can see Julia sets. It's incredible because there's patterns. It's chaotic behavior, but it comes from patterns. It creates patterns. And actually, they use that chaos theory in business. Oh yeah, you've got some of that. That unit would take us after the AP exam. It takes a long time to do it. I studied under Bob Devaney, back in the 80s, and that's how new it is. I know 80s sounds so far away for you, but that's really new. Okay, so we've got some values. We certainly have r less than or equal to 1 where it converges. Where do you think the other place, where was the other endpoint of my interval? Because you think negative 2 is going to converge? R equals negative 2, so it's negative 2 to the n. That's negative 2, squared, negative 2 to the 4th. No, it's getting really negative, right? Negative 2 to the 8th. No, this diverges. Where do you think the other split point is? Negative 1. What happens at negative 1? Does it converge? I'd like to say it does, but does it? R equals negative 1. So a sub n is negative 1 to the n. Now we have to remember this, because we're going to come back and visit this again. This is going to be important. Okay, James? What about this one? It's negative 1. It's 1 squared, right? Negative 1 cubed is negative 1. Negative 1 to the 4th is 1. Is this convergent? No. That's a cyclic point. I can't even go there. It's really cool stuff when you get into it. So this diverges. So the answer is r is going to be between 1 and negative 1, but we're going to include 1. Later on, 1's not going to work. Yes? Oh, cool.
Randomly.
And it's very random, and as long as you got water going on, it goes for forever. That's cool. We can look for it. We have stuff to do. Okay. These are just some definitions. How do you know if a sequence is going to be convergent? Well, first let's understand what it means. A sequence is increasing. I think a picture is the easiest way to do it. If the value of the next element in the sequence is bigger than the first one. That's just saying the next one's bigger than the last one. That's an increasing. It could increase like that. It could increase like this. It's just like increasing functions. This is increasing. What would decreasing look like? This is decreasing, right? If he comes to Minneapolis, I can come and talk to us. But sometimes he's like over our head. So he's just very, very bright. Very smart. He knows what I'm talking about. Okay, but now he's in California. Okay. Any problems with increasing and decreasing? Right. Monotonic, it's always increasing or always decreasing, just like we have done in calculus. Remember that from last year? Always increasing, always decreasing. And how do you know if a function's monotonic? You remember the first derivative of the function. You can't take derivatives of sequences. Derivatives of calculus only applies to functions, continuous functions. Derivative is going to be greater than 0. It's increasing. And f prime of x is less than 0. It's decreasing. Now, I don't do a lot with this. Pretty much you're going to use your intuition, because on the exam, it's going to be multiple choice. It's never going to be complicated where you're going to have to prove that the sequence is increasing or decreasing. You're going to look at it and you're going to say yes. So don't worry about doing the calculus part of this, because I don't really care. Ready? So if I want to look at that sequence and know if it's increasing or decreasing, there's two ways to do it. I could look at the function f of x, which would be 3 over x plus 5, and I could look at its derivative. What's its derivative? Is it positive or negative? It's negative because when I do the power rule, f prime of x, sometimes that's the easiest way to do it. Guess what? You can't do it with factorial. That's the problem. If you could do everything with calculus, this would be so much easier, but you can't. And then it says x plus 5 to the negative 2 times 1, which is negative 3 over x plus 5 squared. So this is always less than 0. So what's true about my function? My sequence then? It's decreasing. But you don't even have to do that. You just look at it. So here's the nth one. How does that compare to the next one? Well, n is going to go up by 1, so it's going to be n plus 1 plus 5, or 3 over n plus 5, and 3 over n plus 6. You just have to take a second and pause. Which one's bigger? I've increased this denominator, so I'm going to divide by a bigger number. This is going to get smaller. That's right. But you have to think a little bit, don't you? It's so easy to get that wrong. Okay, I have to think a little bit. So this is clearly decreasing. I'm fine. If you can look at it and see that it's decreasing all the time, I just have to do a sub n plus 1. And this, if this is this way, it's decreasing. If a sub n is less than a sub n plus 1, it's increasing. And the only reason I care is if I bound this thing. If I find that it has to be trapped between some values. And that should be my last theorem. So are we ready? Yeah, I can. Because I know you guys have questions on these things. And then tomorrow I have a worksheet that has a mixture of sequences, and there's some challenges there. Kind of fun. To me, it's like solving puzzles. No, I have a worksheet. So we're going to finish up 8-1, so you need to have 8-1 done before the end of Thanksgiving break. Get it all done now, you have no homework. Right? And then we're going to get into the tough stuff, which is the series. Okay. You know, I know it's decreasing. You can do this, n squared plus 1, and then this is n plus 1, and then this is n plus 1 squared. And I want to show it's decreasing, so this one has to be this. And you would actually just solve for n if you cross multiply. I'm not too worried about it. Now, let's look at that. And you can just cross multiply, or you can take the derivative, which would be easier, actually. So f of, I would think this is easier. This is equal to x over x squared plus 1. All I care about this is when you look at that, can you tell me it's decreasing? As n gets bigger, is that sequence getting smaller? Yes. Okay, so what do I mean by this boundedness? This sequence, a sub n equals n, to me it's easier to see the picture. At 1 it's here, at 2 it's here. It's not bounded above, but it is bounded below. It can't go below 0. What about n over n plus 1? Let's write some terms out. What's 1? It's 1/2, right? What's the next one? 2/3. What's the next one? These are all going to be positive for now. 3. We'll deal with negatives later. 4/5. Okay? It's bounded, isn't it? It's at 1/2 up below x there. 2/3, 3/4, 4/5. It looks like it's bounded above by 1, and it's bounded below by 0. If you have a monotonic sequence that's bounded above, at least bounded above, and it's increasing, then it will have a limiting value. If you have a monotonic sequence that's decreasing, and it's bounded below, it'll have a limiting value. It could be 0, it could be something else, who knows. So that's really all I care about that. Now, not every bounded sequence is convergent. It's got to be monotonic. See, -1 to the n, is that bounded? What's -1 to the first power? Okay, so it's -1, right? -1 squared is 1. -1 cubed is -1. Is this bounded? Yes. It's bounded above and below. The only way to force a sequence to converge is it has to be monotonic. And you'll look at it. You just use your intuition, because it's going to be, is it going to converge or is it not going to converge? That's all it's going to do. That means for all. Oh, I don't have this. I don't even know what picture. So this means for all. This means there exists. And if you're going to go on in math, you're going to see a lot of this stuff. Yeah, this is therefore. Aren't we lazy? I don't know if I would call myself a mathematician, but math people are lazy. I want myself that way. And this is an element of. Oh, there's tons more symbols. Oh, I won't know them all. Okay. Now, that's the end of 8-1. That's the tough stuff. But let's look at 1 through 16 and see what your questions are. Homework. Oh, there's my book. Do you guys need my book? I'm carrying it with me. Silly me. Okay, you're gonna, and we're gonna do. We have to do a lot of stuff in class to make sure that you understand it. So, out of 8-1, do you have questions on any of those problems? 10.
Yes, I do.
We'll see how well if I haven't studied this. Now you're doing 1 through 16. Those are the first questions. 10. This is 8.1. I don't care. You're gonna work. Okay, what's it say? Find a formula for the general term of the sequence.
You do number 8, too. That we have a girlfriend.
I mean, I could cheat a little bit.
You need to know how to do that?
Not really.
Okay, thanks.
I would probably say a sub, I want odd numbers here. 2n minus 1 is equal to 5, and a sub 2n, the even numbers, is 1. But there's probably a way to do it with an alternating sign. I haven't thought about it. And that's how I do it, but I don't know. I don't even know what the answer is. But you could do like, let's see. See, this would be n, 2 squared plus 1. I don't know. Let's see. But is it converge? All you need out of this is it converge or diverge? Diverge. What's 8? I know. I don't know what the answer is. What is it?
Isn't it 2 times negative 1 to the n plus 3?
I figured it was some sort of alternating sign. Does that work? If n is equal to 1, then it's going to be 2 times negative 1 plus 3.
What's your point?
That's 1, right? And then if n equals 2,
No, but what's the equation?
that's he says works. It's a little off, but it's okay. N equals 2 is 2 times negative 1 to the second power plus 3, which gives you 5. And n equals 3. I know he doesn't have it start in the right place. We can fix that. This is 2, negative 1 to the third plus 3. Yes, it'd be n minus 1 or n plus 1. Very good. You do not have to, guys, you are not going to be required to do this on the exam. They will give you that piece. It'll be more complicated.
So is there any way to like solve that?
Guess and check. Yeah, that's why you don't like this chapter. Because there are no like rules that you can follow. Let's say too nice. What about this one? Guys, am I copying it right? No, they're not. I would break that into, this is easier for me to see. I would break that into parts. This is negative 1, 2, 3, 4. So it's a negative 1 to the n. I might have to adjust that. And this is n. Right? And that works on that top. What is this going to be? This isn't 1 squared. It's 2 squared. So it's what? N plus 1 squared. Let's check. So when n equals 2, I get 3 squared. When n equals 4, I get 4 squared. Yeah, that's it. No, they'll give you, they'll be, you'll see what they'll give you. They will ask you for the nth term. But it will be, this one's not bad. That one's kind of weird. Nothing as hard as 10. 10's hard. No. Okay. 11. Determine whether the sequence converges or diverges. Okay, James, are you going to do this one?
Yeah, sure.
Did you do it?
Yeah.
How'd you do this one?
I got it.
Because all I do is take the limit, which we put plus signs in here, as n goes to infinity of 3 plus 5n squared over n plus n squared. And remember that when n gets big, all that matters is this. N's got to be really big for that to happen, because you do have some other factors there. But when n is into the trillions and trillions and trillions, it's going to 5. Okay, guys, do you have to see someplace else? Okay, more questions. We did 1 through 16. Did you do 16?
Okay, when something diverges, you have to say that it's like diverging through.
Say diverges. I was going to say, 16 is an important one. And here's where we learn our exponents. I'm not joking. Is that 3 to the n plus 2? I really have to make the principles. I need to rewrite that. I could write out the terms, or I can just rewrite that. So how do you write 3 to the n plus 2? Excellent. We're going to be doing a lot of that in this one. And then what about this? Justin, what do I do with this one? I want to write this as a, I don't know. If a sub n is 3/5 the n. You see that I can rewrite that? Times 9. And if I take the limit of this, and we just did that with the r values, remember? The limit of this, the 9, I can pull out as n goes to infinity, and I just proved that to you, that as long as this is a fraction in here, number between -1 and 1, this will go to 0. That make sense? Jordan? Put it on your calculator if you don't believe me. Remember this? R, if I have r to the n, r is between 1 and -1. I just did that today. It will converge. If r is bigger. Had it been 5/3, it would diverge. Okay? Do we even have to know what that is? Marcus, do I have you sit over there? Honestly.
I'm paying attention.
No, you're not. You're screwing around. Okay. Is that enough questions there? Did I get them all? So you just look at it. What's the answer to 12? What does it converge to? 1. How about 14? It diverges. Yeah, it's going off to infinity. That's all you have to do. So it takes longer to explain than it does to do. Doing is fast. Is anybody going to be absent tomorrow? Because I have the worksheet. What's the what? The series will be tougher. We'll get to a place where you have to write a lot, but sometimes you don't. And you're going to have to, now you should be filling in your study guide as we go. Remember the study guide I gave you yesterday? Oh, you were going yesterday?
No.
You're going to have to go to Hersman's room. She's got them all. Who was absent? Oh, yeah, that's what it is. Okay. Yes. So you guys have time to work on the book problems, and I think they're harder than the worksheet.